Okay, let's unpack this. Imagine you've got just a pile of numbers staring back at you.
Yeah, happens all the time. Could be anything, right? Website data, test scores.
Or even, how your sourdough starter is doing week by week.
Ha! Absolutely.
What you really want, though, is to see the story fast.
Mm.
So today we're going to give you the keys, basically. We're diving into histograms, frequency polygons, and ogives.
Free, really powerful graphical tools.
Exactly. They turn that raw data into insights you can actually see.
And what's great, I think, is how these visuals cut through all the noise. We're looking at a guide that's pretty practical about it.
Right. Not just how to draw them, but crucially, when to use each one.
Yeah, to really pull out those patterns hidden in the numbers.
So that's our mission for this deep dive. We want you to get fluent in these visual languages.
By the end, you should feel comfortable knowing, okay, a histogram works best here, or maybe I need an Ogive for this.
Let's ditch that feeling of data overwhelm and just get straight to the visuals.
Sounds good. So where do we start? Histograms?
Yeah, let's start there, the histogram.
Okay, so think of it as a really powerful way to see the shape, the distribution of continuous data.
Continuous data,
Mm.
like height or temperature, things that flow.
Exactly. And the graph itself, it's two-dimensional. You've got bars.
Right, the x-axis, the horizontal one, that's where your class intervals go. The buckets your data falls into.
Mm-hmm. And the axis, the vertical one, tells you the frequency. Basically, how many data points land in each bucket, the height of the bar.
Now, the guide we're using mentions something important. Exclusive form. What's that about?
Ah, yes. That's key for continuous data. If you group data like, say, 11 to 20, then 21 to 30.
That's inclusive, right, because 20 and 21 are included.
Right, and it creates these little sort of artificial gaps between the bars on your histogram. 11 to 20 ends, then there's a gap, then 21 to 30 starts.
But the data itself doesn't really have a gap there.
Precisely, height doesn't jump like that. So to make the visual match the reality, we need to close those gaps. We use an adjustment factor. Often it's 0.5. So 11 to 20 becomes 10.5 to 20.5, and 21 to 30 becomes 20.5 to 30.5.
Ah, I see. So the end of one bar touches the start of the next, 10.5 to 20.5, then 20.5 onwards.
Exactly. That gives you the exclusive form and makes the histogram truly represent continuous flow. No gaps. It's crucial if you're looking at trends, maybe like website load times or something.
Makes sense. So, okay, how do we actually build one? Let's say we have continuous group data already in that exclusive form.
Right. First step, lay out your axes. Class intervals on the x-axis, frequencies up the y-axis.
And choose sensible scales, the guide says. They don't have to be the same scale on both axes.
Correct. Needs to be clear, readable. Then you draw the rectangles, the bars.
The base of the rectangle is just the width of the class interval.
Yep. And the height is simply the frequency for that interval.
So that example in the guide, 0, 8 with frequency 6, 8, 16 frequency 9, 16, 24 frequency 12.
You just draw bars. First bar from 0 to 8 on the x-axis, going up to 6 on the axis. Next bar, 8 to 16, height 9, and so on. They'll all be touching.
Got it. Pretty straightforward. But what if our data starts much higher, like that pocket money example, 150 to 400?
Ah, right. You don't want a huge empty space from 0 all the way to 150 on your x-axis. It wastes space and squishes your actual data display.
So what do?
You use that little zigzag line, sometimes called a kink or a break mark, near the start of the x-axis, near the origin.
Okay, and that just signals.
It just signals, hey, we've skipped a chunk of the axis here because there's no data. So your first bar for the 150-200 interval can start right at 150 on the axis. Much clearer.
Right, focuses the view. Okay, and what about if the data isn't continuous to start? It's given in those inclusive intervals like 11, 20, 21, 30 again.
Well, like we said, you've got to convert it first. Use that adjustment factor.
The 0.5 thing.
Usually, yeah. Find the gap between the upper limit of one class, like 20, and the lower limit of the next, like 21. The gap is 1. Half of that is 0.5. Subtract 0.5 from lower limits, add 0.5 to upper limits.
So 1120 becomes 10.5, 20.5. 2130 becomes 20.5, 30.5.
Exactly. Do that for all intervals, then draw your histogram with these new exclusive intervals.
Oh.
Ensures accuracy.
Okay, one more histogram scenario the guide mentions. What if you only have the class marks, the midpoints?
Right. Sometimes data is summarized that way. Say, class marks 25, 35, 45, 55, 65.
Had to get the intervals back.
You look at the difference between consecutive class marks. Here it's 10, right? 35 minus 25 is 10.
Okay.
You take half of that difference, so half of 10 is 5.
Right.
Now you add and subtract that half difference, the 5, from each class mark to find the boundaries. So for class mark 25, it's 25 minus 5 and 25 plus 5.
Which gives 20 to 30.
Exactly. For 35, it's 35 minus 5, 35 plus 5, so 30 to 40, and so on. You reconstruct the intervals first.
Clever. Then you build a histogram like usual with those reconstructed intervals.
Precisely.
But-
Handy trick if that's how your data is presented.
All right. I think we've got a good handle on histograms now. The guide also mentions frequency polygons briefly.
Another way to show frequency distribution.
It doesn't go deep into making them, but mentions their existence. When would you reach for one of those instead of a histogram?
Well, a frequency polygon is basically made by plotting points at the midpoint of the top of each histogram bar and then connecting those dots with straight lines.
Okay.
They can be really useful when you want to compare two or more distributions on the same graph. Imagine plotting the frequency polygons for, say, test scores for two different classes.
The lines would be easier to compare than overlapping bars.
Exactly. You can see where one distribution is higher or lower than the other more easily. So great for comparison.
Good to know. Okay, let's shift gears then. Ogives, or cumulative frequency curve.
Right. Ogives, these are all about accumulation.
The guide starts with cumulative frequency itself. What's that telling us?
It's just a running total. You add up the frequencies as you go through the class intervals.
So in that example table, CI, 2025, frequency 3. Then 2530, frequency 6. The cumulative frequency there is.
It's 3 plus 6, which is 9. It means 9 data points fall below the upper limit of 30.
And the next interval, 3035, has frequency 10. So the cumulative frequency is 9 plus 10, which is 19.
You got it. It just keeps adding up.
Yeah.
The last cumulative frequency will be the total number of data points.
And the point of this table is?
It lets you easily see how many observations fall below a certain value. Super useful for things like percentiles, finding the score below which, say, 25% of students fall.
Okay, makes sense. And from this, we build the Ogive curve. The guy talks about the less than type. How's that done?
So you need that cumulative frequency table first. Then you plot points.
You
use the upper class limit on the x-axis and the corresponding cumulative frequency on the a-axis.
Upper limit and cumulative frequency, got it.
So for that 25-30 interval, the upper limit is 30 and the cumulative frequency was 9. So you plot the point 39.
And for 3035, the upper limit is 35. Cumulative frequency 19. Plot 3519.
Exactly. You do that for all your intervals. Then you connect those points with a smooth freehand curve. Not straight lines like the polygon, but a curve.
That example with the student marks, 5, 10, 10, 15, etc. They calculate the cumulative frequencies, 7, 16, 28, 36, 42. Then they plot 10, 7, 15, 16, 20, 28, 25, 36, 30, 42, and draw the curve connecting them.
Precisely. And you'll notice that less than Ogive curve is always rising, or at least staying level. It never goes down.
Because you're always adding frequency, right?
Yeah.
Accumulating.
Exactly. It starts often implicitly at the lower limit of the very first class on the x-axis with 0 cumulative frequency, and it ends at the upper limit of the last class, reaching the total overall frequency on the y-axis.
So it gives you that visual sense of accumulation across the range.
That's the idea.
Okay, so let's just quickly recap. Histogram's great for seeing the shape of continuous data. Need that exclusive form, watch out for gaps.
Right, and we know how to handle inclusive intervals or just class marks.
Frequency polygons, good for comparing distributions on one graph.
Yep, connecting midpoints.
And the Ogives, the cumulative frequency curves, show us how data builds up, useful for percentiles and seeing that accumulation trend.
You've pretty much nailed the basics. It's a solid toolkit for turning numbers into pictures.
Yeah, you now have these tools to take that messy data and make it tell its story visually, which is often much easier to grasp.
Absolutely. And that's the real aha moment, isn't it? When the visual clicks and you understand the pattern.
So here's something to think about. How could you use these? Think about data in your own world. Work, hobbies, whatever.
Yeah, maybe sales figures, survey results, maybe fitness tracking data like you mentioned.
Applying these simple graphs could actually reveal patterns or trends you hadn't noticed before.
So the question to leave you with is, what stories might your own data be trying to tell if you just gave it the right visual voice? What could a histogram or an Ogive reveal for you?